Okay. Oh, this is interesting. My shirt is slightly on the green side, so green screen's going to be fun today. All right. So I've just finished my newsletter. It's on explicit versus diagnostic garbage collection, and you might have seen people calling System.gc explicitly in their code. This is not a good idea. They're trying to help the garbage collector. Usually they actually cause more damage than anything good. But what I didn't realize is that we can also cause a diagnostic GC, which is done by tools like jcommand. And even if we disable explicit GC, we can still do diagnostic GC. So, all right, so there we go. So this is my new newsletter, and yeah, a bit of a story here. I actually learned about this in a course that Kirk Pepperdine wrote, and we made a recording of it a few weeks ago. And you can get that. There's a link in the newsletter. You'll see it if you go to the newsletter. And but it's actually really easy to find a memory leak. That you simply look at the generational count. It points you to what the culprit is, and then you start tracing the roots of these objects to find out where you're from. We had some very interesting stories with water leaks where we live, because we were really far away. We were about several hundred meters away from the water meter, and then occasionally a farmer would either run over our water line with his truck full of watermelons, or otherwise pull out a chainsaw and accidentally cut through it. And anyway, so we got this big, massive bill. My last bill, I opened it and I was like, no, this can't be right. This is over $1,000 of water. I think that can't be. Normally it's like maybe 100 or 200 for 3 months. That's what I normally pay, but what you normally pay. But and there was a water leak that somebody had caused and hadn't fixed or hadn't told us about it. So anyway, so we luckily they reduced the bill. But the lesson is, even if you have a small leak, it can cause a lot of damage. If you have a leak, rather fix the leak, otherwise they're going to cause problems. And with memory leaks, they're actually really easy to fix. As I said, you just look at the generational count, you look at the GC roots, and find out where this object is being leaked, and fix it. We're done. It's very easy to do. As I said, we've got this course that we've recorded. You can find that from the newsletter. But the point was, during the course that we recorded, Kirk mentioned this thing about the explicit versus diagnostic GC and how it actually appears differently inside the GC logs. Now we can turn off explicit GC with -XX : plus disable explicit GC, but we cannot turn off the diagnostic GC. And I didn't know about this. I've been using Java for a very long time, and I did notice that I think in Java 8 I tried to use jcommand to do an explicit GC, what I thought was an explicit GC, and it didn't work. Jcommand stopped me. And I also noticed that with JVM and with JConsole, when you click on the collect memory, whatever it's called, perform GC or something like that, button, that it didn't work if you disabled the explicit GC. So anyway, so I wrote this code to try it out. Basically, let me go to this nicer looking code. And we've got an MX bean over here, and what I'm doing on that is just to turn verbose GC on every time when you call it, so that you don't have to set it up explicitly. It's always on. And I just make some objects that's hopefully going to start the GC bit, and then I'm just reading input and waiting for waiting for somebody to press enter. So, wait, hold on, this is wrong. I must turn this off. Turn all of this off. So this is all off. So now it's running, and you can see there were some GCs happening, and if I press enter, it's going to call System.gc. This is what we call the explicit GC. And you can see there's this pause full. The effect is actually different depending on what garbage collector we're using. If you be using Shenandoah, then by default that's going to trigger a concurrent GC. It's going to start the concurrent GC. But if you have G1, by default it's going to do a full GC. And then so it's not doing the full GC. It's done the full GC, and we can turn that off. I'll do that in a second. And then if we connect with something like JVisual VM, let's start that. Visual VM. Sorry. That's actually it was Java 22. So I always try to run Visual VM with the same VM as I'm as a code I'm running on. So here we go. Applications. That's this diagnostic versus explicit GC. And if you go to monitor and you click on perform GC, let's go back to our application that's busy running. Perform GC, you can see it does the same pause full system GC. So that MX bean that we're calling here actually does a system GC. And you can actually get to that via several different ways. So one way is like this. The other way is you can go to somewhere, get the MBeans somewhere. Let me do it a different way. There's a plugin which I haven't installed. So let's also connect with JConsole. So that's another one we can use. JConsole. Unfortunately, the font's a bit small on the JConsole. And let's see what that looks like. But it's the same idea. Is we've got the memory here, and we can say on the memory we can say perform GC, and again you see the pause full system GC coming out. But we can also go to MBeans, and here we can go to Java Lang memory and go to operations and again do a GC. So these are lots of ways to do this explicit GC. And this is what we can turn off. So if I run this again, what you'll notice, let me do it again. Run it with the VM parameter minus XX plus disable explicit GC. So turn it off, run it again, and now when I press enter, it doesn't do any full GC. I've turned it off. And what you'll now notice, if I go and I reconnect with JVisual VM, let's do that as well. That's going to be reconnected. Was that right? I'm not sure. Let me try it again. Come on. Yeah, it tends to tends to do this. Tends to crash. Let's see what's happened there. It seems to have worked, but it says it worked. Didn't really work. Let's go with JConsole rather. It's the same thing. We're going to close this connection, and we're going to reopen it. And nothing seems to work at the moment. Okay, I'm going to kill these processes. Not the best demo of what you can use. So Visual VM again, we'll reconnect to that process, which is our diagnostic versus explicit GC, and go to monitor, and we're going to say perform GC. This is our process here, and you're going to see that it doesn't do anything. It doesn't do the actual collection. Okay. Similarly, if we go to JConsole, JConsole, and connect with that. Let's go back to the diagnostic versus explicit GC, connect to it, and we go to memory and perform GC, and it doesn't do anything. So we go to there's the output. It doesn't do anything. And the MBeans, the same thing. If you go to Java Lang, memory, operations, and GC, it doesn't respond. However, if you go to ComSun management, diagnostic command, operations, here we actually can see there's a GC run, and if you run that, it does do the GC. It does a diagnostic command GC. Now, I wouldn't recommend that you do it this way because it's quite cumbersome. A better approach is to do this with jcommand. So if you say jps, you get the name of the class, and then you can simply say jcommand and copy and paste the name of the class, which is really convenient because that way you don't have to remember the PID every time, and you can rerun the jcommand as often as you want on different processes that you've run. You don't have to every time look for the PID, which is kind of cumbersome. So if you say gc.run, we can see it's now done the GC, and if you go back here, you can see again we've had a diagnostic command. So that was from jcommand. So most of the time you're going to do it that way. There is a way to do it, which I'll show in the newsletter, like so, diagnostic command, gc.run, and it's kind of a backdoor to the system. We're not really supposed to be able to do this, and you sort of have to guess what the object name is. It's something like comsun management : and the type is diagnostic command. I didn't spend too much time on trying to figure this one out. What I'm saying is there might be another way to query what all the beans are that you've got. There's got to be a way to do that, but I didn't do that. I didn't actually spend that much time on finding out how to query everything in there. I just basically looked at jconsole, looked at what the package name was, looked at the name of the actual mbean, which happens to be diagnostic command, and the name of the method, which is gcrun, without any parameters. But this would allow you to sort of really force a GC. Even if somebody turns it off, that you can still go and call it. It actually, when you do the diagnostic command, it calls a method in the C layer in the diagnostic bean, and it looks, if you scroll down a bit, you can see it looks like this. It's basically says heap collect, and it does the cause, which is it's a diagnostic command to run. Versus if you do a System.gc, which is also what is called from the mbean by default, and that then internally says if not disabled explicit GC, then do the actual collection. And here they also take into account the concurrent, which also happens inside this other one. So the other one also does take into account whether or not you wanted to do it with concurrent rather than the full GC. And the Shenandoah, I think I mentioned this, by default, when you say System.gc, it will start to trigger the concurrent GC. Whereas if you have a parallel, the G1 collector or the ZGC, by default, when you say System.gc, it's going to do full GC, which is really expensive. And I tried this out. It seems to be that G1. With G1, you can also set it up. You can say -XX : plus explicit GC invokes concurrent, and that then also goes and triggers a concurrent GC rather than a full GC. So anyway, this was quite fun. I hope you enjoyed this, and hope you enjoyed the newsletter. And if you haven't signed up to the newsletter, you really owe it to yourself, to your professional development, to sign up to my newsletter. All right, thanks for watching.